So in the last video, we were revising the idea of alcohols. We know these are a homologous series of organic compounds which have the hydroxy functional group, or the OH. We use OL in the end, for example, methanol, ethanol, propanol, and so on. One of the methods to make alcohol was the addition of steam, where H goes on one carbon of the carbon-carbon double bond, OH goes on the other. Similarly, we compared the idea of addition of steam and fermentation. We saw that addition of steam required alkene and steam, while fermentation required yeast and carbohydrates. Addition of steam was much of a chemical process, fermentation was a biological process. Addition required 300 degrees Celsius, while fermentation took place at room temperature. Fermentation could be used to make ethanol only, and this was a comparison from the last video. We know that addition of steam method can make any alcohol by adding H and OH on the carbons which have double bond, like ethene makes ethanol. Propene, which has 3 carbon and a carbon-carbon double bond, it makes propanol by addition of steam. Similarly, isobutene would make isobutanol by the addition of H and OH on the exact carbons which have the carbon-carbon double bond. So similarly, we know that alcohols always have OH on them. Let's revise the fact that alcohols are a homologous series. We know what homologous series are, right? So alcohols are a homologous series of organic compounds that have the hydroxy, which means OH functional group. This is not a minus in the beginning, it's a bond, so OH functional group. The line represents that OH will be bound to the organic compound. So OH is not a minus OH, it is a bond with OH. So this is the, I should write it, yeah. This is the hydroxy group. It is a functional group. Now, let's recall. For example, I have 2 carbon atoms, and for example, I've got hydrogen atoms over here, and I have an oxygen atom and hydrogen atom. These are the carbons. These are the hydrogen atoms bound to the carbon, and there is oxygen and hydrogen over here. Now, we know that there is single bond between the carbons and between the carbon and hydrogen atoms. So over here I am trying to draw a dot and cross diagram to show that there are bonds present between the carbon and hydrogen atom. This is the bond between carbon and hydrogen atom. Similarly, over here the 2 dots represent a bond between the carbon and carbon atom. Oxygen also makes a bond. This is a single bond, by the way. So oxygen also make a bond between the carbon atoms, and that is a dot and cross. Oxygen has another bond with the hydrogen. So oxygen makes one single bond. It makes a single bond between the carbon and oxygen atom, while there is another single covalent bond, single bond between oxygen and hydrogen atom. So these are the electrons represented by dots and crosses. If we remember the idea that they have OHs, we would say that they are not hydrocarbons because they also contain an oxygen atom. They also contain an oxygen atom, so they are not hydrocarbons. Alcohols have their own general formula, which is CnH2n plus 1 OH. They have their own set of properties. The another formula that you find is CnH2n plus 2O, but I think the previous one is more easier. Let's try some ideas on alcohols naming and their formula writing. For example, we know that carbon 1, 2 and 3 are called methane, eth and prop. So the naming of alcohol is going to be methanol, ethanol and propanol. We use the suffix ol in the end. So it's methanol, ethanol and propanol. We know that the general formula of all the alcohols is going to be CnH2n H 2n plus 1 OH. Now n could be any number. For meth, it's going to be 1. So if carbon is 1, hydrogen should be twice plus 1, which means 2 times 1 plus 1, which becomes 3. So the formula becomes CH3. We don't write a 1 with the carbon, so CH3, and OH is a constant functional group. So OH going to be constant over here. Similarly, in the case of ethanol, carbon is equals to 2. So hydrogen, according to the general formula, has to be twice 2 plus 1. 2 times 2 plus 1, which is 5. So it becomes C2H5OH. For propanol, carbon are 3 in number. So if carbon is 3 in number, we know hydrogen has to be 2 times 3 plus 1, which becomes 7. 6 plus 1 is obviously 7. So it's C3H7OH, propanol. You can notice one fact, that since it's a homologous series, every time we increase 1 carbon and 2 hydrogens. From ethanol, you can see carbon increased by 1 unit and then hydrogen increased by 2 units. Similarly, for butanol, there are 4 carbons, pentanol has 5 carbons, hexanol has 6 carbons. Let's try out their formula writing. If carbon is equals to 4, hydrogen has to be 2 times 4 plus 1, which is 8 plus 1, 9. So the formula becomes C4H9, and OH is a constant for alcohols. Pentanol has 5 carbons, right? So if carbon is equals to 5 in number, hydrogen has to be 2 times 5 plus 1, which is 10 plus 1, 11, C5H11OH. Now hexanol has 6 carbon atoms. So hydrogen is going to be 2 times 6 plus 1, which is 12 plus 1, 13, and we get OH. So C6H13OH. This will help us with the fact that how alcohols are named and how their formula is written. So we'll hopefully remember the basic ideas about alcohols, because in the next video we're going to be talking about their oxidation. So stay tuned, guys.